Hello everybody and welcome back. We're going to be continuing on in this video with the 2013 CSMC. We're on to question number 5 in the Part A portion of the competition. So we just need the final answer. We put it in the little box provided and we move on. Okay, so let's take a look at question number 5. So each of the positive integers 2013, which happens to be the date, the year the contest was given, and 3,210 has the following three properties. It's an integer between 1,000 and 10,000. So what they mean is it's just a 4-digit integer. Its 4 digits are consecutive integers. So 0, 1, 2, 3, 0, 1, 2, 3. And it's divisible by 3. In total, how many positive integers have these three properties? Okay. So each of the digits being consecutive integers means they're all going to be distinct. So once we get a set of 4 digits that work, then we're just going to need to multiply the number of cases by 24. But we'll get into that in a little bit. We're just sort of rambling, thinking of ideas right off the top of our head. So we need a 4-digit integer, 4 consecutive integers. So they're going to have to be between 0 and 9, otherwise we're not going to have digits. And they need to be divisible by 3, and I think divisible by 3 is definitely the key. So let's explore this a little bit more. We'll come back to that multiply by 4 factorial, which is 24 in a little bit. All right. So we'll give our digits names, A, B, C, and D. Well, then we can make a slightly broader statement, A, B, C, D. We don't know what order they'll appear in the numbers we're talking about, but we do know we can order these guys because they are consecutive. So A plus 1 is B, A plus 2 is C, A plus 3 is D. Okay, and we want our number, A, B, C, D, or C, D, A, B. We want this to be divisible by 3. In order to be divisible by 3, the sum of the digits of our number has to be divisible by 3. So think 36. 3 plus 6 is 9. 9 is divisible by 3. Think 42. 4 plus 2 is 6. That's divisible by 3. How about 46? 4 plus 6 is 10. Not divisible by 3. 46 is not divisible by 3. Okay? So for a 4-digit number to be divisible by 3, A plus B plus C plus D must be divisible by 3. So that means 3 divides A plus B plus C plus D, but we know B, C, and D in terms of A. So 3 actually divides, if we work that out, it's 4A plus 6. Okay? A plus 1 is 2A plus 1. If you add on A plus 2, you get 3A plus 3. If you add on another one, you get 4A plus 6. Okay? So 3, that divides 6 all well and good. So that means that 4A needs to be divisible by 3. Right, if you have 3 divide 2 different numbers, he'll also divide their difference. So 4A plus 6 and 6, they're both divisible by 3, so their difference, which is 4A, must be divisible by 3. Now, since 3 is a prime, either 3 divides 4, which we know is absurd, or 3 divides A. So in order for A, B, C, and D to even be potential candidates for digits for forming a number, we need 3 to divide A. Now A happens to be the lowest one, and so A could be equal to 0, or he could be 3, he could be 6, or he could be 9, but he can't be 9. We can rule that out right away. Otherwise, B is equal to 10, and we've got ourselves a problem. So, from 3 divides A, and A between 0 and 9, we could get A as 0, 3, 6, or 9. But A is supposed to be the lowest of our digits, so he can't be 9, because that's way too high. So our candidates for digits are 0, 1, 2, 3. Well, hey, these are the ones we saw in the first the examples we saw at the start of the question in the preamble. So there's 2013 and 3,210. What else could we have? Well, we could have A as 3, and then that gives B as 4, 5, and 6. Or finally 6, 7, 8, and 9. Okay. So these are the digits we want to use. How many numbers can we make with them? So any way we arrange these guys, we could have 3, 4, 5, 6. We could have 5, 4, 3, 6. We could have 6, 3, 4, 5. We could have 6, 5, 4, 3. Anything we want. They'll always make a satisfactory 4-digit number. The only exception, and the reason we haven't included the first case, is because a leading 0 would cause a problem. Okay. So there are 4 factorial. We saw an earlier question with factorials. One of the big uses of factorials is for counting arrangements of things, permutations. So there are 4 factorial equal 24 ways to arrange four different we'll say digits. So each of these possible sets of A, B, C, D, there's 2 of them. Each of them gives us 24 different 4-digit numbers. So that in total gives us 48 different 4-digit numbers. Now the other case, 0, 1, 2, 3, 4, we can't have 0 as the leading number. Remember, we've got to be between 1,000 and 10,000. So once we choose one of them, say we choose the 2, we've got 0, 1, or 3 remaining. The other 3 can be in any order. And this question is not so difficult. I mean, they're 4 digits, so you probably could list them all out if you were unfamiliar with choices and factorial, but that's something you really should be used to, especially for the senior level contest. So they can be in any order. So 3 times 3 factorial. 3 for the choice between 1, 2, and 3 as to what our leading digit is. 3 factorial, the arrangement of the leftover digits. So what's 3 times 3 factorial? Well, 3 factorial is 6. So this is 18. So we have 48 plus 18. 48 because of the previous cases and 18 from the other cases. And we combine those together and get all the cases, all the 4-digit numbers that work. So that's 66 4-digit numbers. So we get 66 4-digit numbers satisfying the conditions. Okay, and that was all the question asked us to do. An extension would be figure out and if in the ordered list where 2013 might be, something like that. But we were just asked in total how many positive integers have these 3 properties. 66 of them, 48 of them coming from 3, 4, 5, 6 being rearranged, and 6, 7, 8, 9 being rearranged, and then there's an extra 18 from 0, 1, 2, 3 being rearranged, because 0 cannot be the leading digit. Alright, so that concludes question number 5. Hopefully you'll join me in the next video as we finish off part A with question number 6.